For example 1, we want to divide x plus 1 into the given polynomial and see how that relates to the graph. So to set this up, I'm going to say x plus 1 divided into 17x cubed minus 79x squared minus 41x plus 55. And my first choice is going to be, what do I multiply x plus 1 by to get as close to 17x cubed as possible? That choice is going to be 17x squared, because I get 17x cubed plus 17x squared. I now subtract this off, and the x cubes cancel. That's perfect. We have negative 79 minus 17, so we have negative 96x squared. And I'll bring down the negative 41x. All right, great. So now I want to cancel a negative 96x squared, so I'll multiply by negative 96x, gives me negative 96x squared minus 96x, and here I'm taking the difference of these two things, so all that's left over is going to be a positive 96 minus 41. Oh, and that's 55x, and I'll bring down this plus 55. So my last step would be to cancel as much as possible 55x. So I'll have to add plus 55 at the end, but I get 55x plus 55. I see when I subtract this thing, it's going to work out perfectly. The difference is going to be exactly 0. A remainder of 0 means x plus 1 did in fact factor the polynomial. Now here's how this relates to the graph, and it's a really important fact. If you have a factor of x plus 1, it has a corresponding 0 of negative 1. All that means is if you put negative 1 in place of x, it makes the factor 0. Now if you look at the graph itself, I'll mark it on here, but you have this point here. That point is at x is equal to negative 1, and it is a 0 of the function. So really, we could have just looked at the graph. I could have said, oh, the spot right here has an x value of negative 1, and anything that is a 0 would give me the following factor. So I like know ahead of time that x plus 1 divides into this polynomial. So that would have saved us all of the work we just did over here. Again, you could just look at the graph and say, oh, negative 1 is a 0, mark it down. Then you can say, well, the corresponding factor would have to be x plus 1, because if you put in negative 1, it makes it 0. This must divide the polynomial. You can continue with the graph that we have here. Like, there's another spot over here. There's this point. That has an x value of negative 5. So, positive 5. So it must be that x minus 5 is a factor. So we could have divided by x minus 5 and ended up with a remainder of 0 too. So using the graph is actually really useful. It tells you exactly how to factor your given polynomial. Like, I could skip all of this polynomial division and say, well, it's got a factor as x plus 1 times x minus 5. Now, there's a third one, right? I mean, this one isn't as obvious. Like, there's a spot here. It's not an integer. I don't know what it is. If you did, in fact, know what it is, this would just factor the polynomial for you. It's not very difficult to reason out what it must be. We can actually use the following numbers, 17 and 55, to figure out what the remaining factor is. I'll actually fill it in. It's got to be 17x, and the reason is you have a 1x, and a 17x, which multiplies to give you 17x cubed. Now this 1, this negative 5, and whatever goes over here has to multiply to give you positive 55. Well, that's got to be 11. So that's the remaining factor for this polynomial, 17x minus 11. So this new perspective is really useful. So you can do polynomial division, there's nothing wrong with it. But if you have a graph and you also know all of the zeros of the graph, you can like almost instantly factor the polynomial. And I'd like to try that without division. Just use the graph to factor the polynomial in a couple of examples. All right, so in example 2, again, the goal is to factor 2x cubed minus 3x squared minus 39x plus 20. So I just went right to Desmos, and I entered in this equation, and this is the graph I got. I had to, scale it a little bit, and of course you should practice that as well. But really all I care about is where it is crossing the x-axis. So I'm actually gonna, note that, well, here's a point. There's a point here, and there's a spot here. So the zeros, I'll write it off to the side, they are -4. Let's see, one of them is 5. This one actually looks like it's at a half, 1/2. Now we should write down the corresponding factors for these zeros. Well, it's got to be x plus 4. I'm going to write x minus a half for the time being, and then I'm going to put x minus 5. Again, because if you plug those numbers in place of x, you get 0 back from each factor. So I wrote down the zeros, and these are the factors. So it should be that the product of these 3 factors is equal to this expression here. So that is, if you multiply x plus 4, x minus a half, and x minus 5, that factors the polynomial that we started with. And you could double check this by, all right, we'll look at the coefficients in front of the x's, which are 1, 1, and 1, and we'll look at the constant terms, which are 4, this is -1/2, and this is -5, and it should be that the coefficients in front of the x's multiply to the 2, so that's because we had a 2x cubed, and the red ones should multiply to a positive 20. And I see that they in fact don't, but we're really close to our final answer, and here's what went wrong. If we look at this middle factor here, there's another way that you could write this one. I'm going to write it as 2x minus 1 as opposed to x minus a half. Notice that 1/2 makes both of these 0. So let's rewrite the problem out. It's x plus 4 times 2x minus 1 times x minus 5. Okay, now if I multiply these together, I get 1 times 2 times 1. Okay, that gives me my 2x cubed. I then have 4, -1, and -5. That's going to be a positive number, and it's going to be positive 20. Here it is. This is the factored form of the polynomial. So I wrote a lot of extra work that probably won't be necessary after you try this a few times, but here's the idea. You go to your graph, you mark down what you think the zeros are, and I listed them. I then wrote down the factors. I adjusted this one so I would have a 2 in front of the x and then a 1 at the very end, and then I just listed those out. This is a really fast way to factor any given polynomial. You go to the graph, find the zeros, write down the factors. The product of these 3 things has to be equal to the original problem, and there's no division that was necessary. Okay, and just one more. I want to factor 4x cubed plus 4x squared minus 55x minus 100. And I noticed on this graph, after I looked at it in Desmos, that there's only 2 places where it's actually equal to 0. I mean, here we have a 4x cubed, which the degree is 3, and I'm only seeing 2 spots that make it 0. Maybe that won't be an issue, but let's see what's going on. So here at 4, we have a 0, but also here, this is going to be -2.5. That's a 0 as well. So if I'm being really careful here, that's -5/2. I'm writing it as a fraction because for x equals 4, I know the factor is going to be x minus 4. But for x equals -2.5, I'm going to write this as 2x plus 5. Okay, it became positive because the negative 5 halves was negative. The 5 went at the very end, and the 2 went in front of the x. So these are my only two factors that correspond to given zeros. So I'll write that as 2x plus 5 times x minus 4. And that's all the information I have, but I know that this won't multiply to a 4x cubed. This would only multiply to an x squared. So what's going on here? If you look at this 0, notice that it stays on the same side of the graph. That's because the exponent at this 0, it shouldn't be a 1, it should actually be a 2. So I'm going to place an exponent of 2 on this function. Maybe I'll write that this one is a 1. I think that this is going to be it. If you think about it, on this very first term, you have an x squared multiplied to an x to the first will give you an x cubed. But even more importantly, if you square 2, you get 4. And if you multiply it to 1, that would give you that 4x cubed that we're looking for. Also, we should end up with this negative 100. Well, if you square 5, you get 25. And if you multiply that to negative 4, you get a negative number. In fact, you do get negative 100. So I guess that's what I'm talking about for this being a very fast way to factor any given polynomial. You go to the graph, I quickly located the zeros, I wrote down the factors. In this one, I had to go a step further. I had to adjust one of the exponents. But I did that because I knew this was like something to the power of 2, or at least an even power, because it stays on the same side of the graph. The factor over here, it goes directly through the axis, so I knew the exponent had to be an odd number, like a 1. In fact, it looks more like something to the first power. It looks almost linear at this point. And that is it for factoring this polynomial.